Now let's see few important terms that you will come across in PCA, which are loadings and scores. First, we'll see what loading is. Simply put, loadings are interpreted as the coefficients of the linear combination of the initial variables from which the principal components are constructed. So remember, principal component is nothing but a linear combination of the original predictor variables. So if they are a linear combination, then obviously there will be coefficients by which that linear combination is formed. Hence those coefficients are called as loadings. The higher the loading, the higher is the correlation of that variable with the respective principal component. It basically gives us information about the important variables or contribution of the variable for constructing a particular principal component. Now loadings are the elements of eigenvectors, and it will always lie between -1 to +1. Eigenvalues are the diagonal of variance-covariance matrix of principal components, and it is equal to the variance explained by PC. Then we have scores. Scores are the representation of feature x, that is the predictor, in the principal component space. So scores vector is equal to x, the matrix of predictors, multiplied by loading vector. Let's understand it through an example. Let's assume below is our data, and let's just assume that this is scaled. Now after performing PCA, we get our PCs as below. Each element of PC is a loading. We can calculate our new data in the rotated space or in the principal component space by simply multiplying loadings to the predictors. So what is happening here is each predictor is now becoming a linear combination of all the predictors. Now the values in the above table are called loadings, and the new data in the rotated space is our scores. So that is how we calculate loadings and scores.